Okay, we break up. When's the next time I see you guys? Tomorrow? Is that tomorrow?
Yes.
Yeah.
I'm going to talk about it tomorrow. I didn't budget time for homework today. I kind of want to finish the last section in finance today, so we'll talk about that tomorrow. It's like someone used my green chalk to do an entire lecture. It's like all this green dust over here. Let us move on. Last time we were talking about saving up for your kids' future to send them off to college. We are going to look at a different perspective now. That ended our topic with future value of annuities. Now we're going to talk about present value of annuities. Remember, an annuity is just a sequence of payments. Last time we figured out, given some interest environment, how we should make payments to build up to some lump sum, like a money for college or something like that. Now we are going to want to kind of turn that backwards. Recall, we had this formula, A equals P1 plus R over N to the NT. This was the compound interest formula for something compounded n times per year at an annual APR, at an APR of R for some time t. And notice that this is what we deposit in order to get that at some point in the future. I actually want to turn that around. I actually want to solve for P, which is going to be A over 1 plus R over N to the NT. Or you can think of this as A times 1 plus R over N to the minus N. Use the laws of exponents. And so this guy, one way we look at this is we think of the P as a present value. So you might want to look at this from the perspective of what money should I deposit now to have that amount of money in the future. Okay. And so this is what some future value is kind of worth now to you. So this here is the present value of some future sum. Okay. So let me give you just a simple example of us just using the formula kind of backwards. Normally we start here and figure out what's this going to grow into, but sometimes if we already have an idea of what something's going to grow into, we want to know what we have to kind of be doing now. So here's an example. So that's kind of the perspective we want to take for today's lecture. Well, not, this is kind of leading into the perspective that we're going to want to take. Okay? So we're thinking of some future sum. I want to know what do I deposit now to obtain that future sum based on interest. Now, of course, I don't have to put in the $1,000 now, because whatever I put in now, it's going to grow with interest over time. So clearly I have to put in something a little bit less than 1,000, but I just want to make sure that with that interest, it grows to 1,000 in 1 year. Okay? So what is that $1,000 1 year from now worth to me today? What is it worth to actually pay for that under these conditions? And you can just use this formula. So this means here we have the present value. It's equal to Where? In this case, the amount I want in the future is 1,000. R is going to be 0.05. Our T is going to be 1. Our N is going to be 12. It's compounded monthly. This means what this is worth to me now is going to be 1,000. 1 plus 0.05 over 12 times 12 times raised to the 12 times 1. And what's that going to be?
I got 951.32.
951.32.
338, yeah, for going for.
Yeah, we agree? Yeah.
Why is the exponent not negative?
It should be negative.
Alright.
Did you put it in negative?
Yeah. I think it's right.
That's important.
I put that in right.
But what we're gonna do after this, like if you forget the negative power, you're gonna get like a negative number as the answer, and so that should be something you look out for. If you're like on a test or something, you're getting a negative number. Am I losing money? Probably you forgot a negative sign in one of these formulas. So yeah, that should be a negative power. 951. So, in other words, to have $1,000 1 year from now in these conditions, today I would have to deposit 951, which saves me like $48 and change, right? So that's $48 and change that I can gain from the interest that I don't have to pay out of my own pocket. Now, of course, like I said, it's not a lot of money. Well, $1,000 isn't a lot of money to begin with, but compounding over 1 year usually isn't going to give you that much return. It's over multiple years, many years, where you'll start to see the difference. But that is something, right? It's almost $50 that I saved. Here's a different question. Okay. Now this one is slightly more involved than that question. Okay. So here I just want $1,000 1 year from today, but here's a question. What should I deposit now? If I want not just $1,000, but $1,000 every month for the next 5 years. Now that's a very different question. Here I want to know what is the lump sum I can put into an account now so that I can withdraw $1,000 every month for 5 years and not run out of money until the 5-year period is up. Now, assuming, of course, some particular interest schemes on the account, right? That's a very different question. It's not like just a one-time deal, right? Oh, I just need $1,000. Okay, I'm good. No, $1,000 repeatedly, right? How much money do I have to deposit now to actually get that, right? So that's the question we are going to answer. So I'll give you some time to write that down. And then we're going to figure out how to actually answer that question together. So the schema that we use to answer this is called the present value of an annuity. So we want repeated regular payments, and we want them to happen in the future. What do we need to do now to get that in the future? So here's what we're going to do. Let R be the regular payouts we want in the future. This is going to be very similar to deriving the sinking fund formula. So here's the now, and let's say we're using m periods. Right, so for the previous example, m would be 60 in this case. I want 60 payments of $1,000. Okay? So here's period 1, where I would get R dollars at that period. Here's period 2, where I would get another R dollars here. Period 3, where I would get another R dollars, dot, dot, dot. Period m minus 1, where I would get R dollars, and here's period m, where I would get R dollars. The goal is, what do I deposit now so that I can withdraw R dollars multiple times in the future? And so we're kind of going to use the previous formula, but of course we're going to be having to do a sum here. So the present value is just going to be the sum of the present values. Of each payment. So basically you just look at them one at a time. What's the first payment worth now? What's the second payment worth now? What's the third payment worth now, and etc. And then you're going to add up all these monies. So, of course, over time, this first payment here is going to be larger than that one, because these guys are way towards the end. They get a long time of interest buildup, whereas guys towards the beginning of the list don't have a long time of interest buildup. So to get that first payment, it's going to require a larger lump sum, but the lump sum that I have to deposit gets smaller over time, and I want to know what is that total that I have to put down now to be able to do this. So the present value, using the previous formula, if R is like the A, the future value I want to get, I know what I would have to deposit now to get that guy is going to be R times 1 plus R over n to the minus 1 by plugging in, because I get hit with the negative power and I get hit by interest once. This guy has some time, he's going to get hit by the interest twice. This guy is going to get hit by interest 3 times. Right? But the negative power is kind of saying that we're living in the past and we're thinking about what would have to happen like 3 cycles ago to get this now. And this will continue. And so this guy here is going to get hit m minus 1 times, and then this guy here is going to get hit by interest m times. Now what is all this worth to me now? Well, it's going to be the sum of these. And we saw something like this before. So we're going to actually do a very similar trick. I'm going to think of this as equation 1. I am going to multiply it by something convenient so that I can subtract a bunch of guys. Let's multiply it by that 1 plus R over n. Multiply this by 1 plus R over n, you just have R left. Multiply this by 1 plus R over n, we have R to the 1 plus R over n to the minus 1. 1 plus R over n to the minus 3. Here you'd have 1 plus R over n to the minus m. So this here is minus m plus 1, and so it's minus m plus 2. And this is going to be 1 plus R over n to the minus n plus 1. I'm going to call that equation 2. And I am going to actually do that whole subtraction thing again. I'm going to want to subtract, I'm going to take equation 2 and I'm going to subtract equation 1. So if I take this minus that, I'll actually be left over with R over n times PV. Because I have the 1 PV here minus the 1 PV there. R subtract, there's no other R to be subtracted, so that R stays. And then we have all these cancellations here. So this guy gets subtracted by that guy, this guy gets subtracted by, this should have been the 2. this guy will get subtracted by the guy right beside this. This guy is going to subtract the guy right before that. This guy is going to subtract that guy. And pretty much now I only have one term left in the top, so this is going to be minus the r times 1 plus r over n to the minus n. So that is subtraction of the two equations. And at this point I can simplify. I can solve for the PV. R is a common factor, I can factor it out. And I have that formula for the present value. So it's not like I want to know what I have to deposit monthly to build up to some large sum. I want to know what lump sum I have to deposit now to have payments in the future. And that's going to be the formula. Now, typically we have the usual notation change here to make things a little bit more intuitive. And the R is usually abbreviated PMT, which stands for payments. Of course, the M we know is going to be N times T. That tells us the number of times we're being hit by interest. And so this pretty much becomes PV equals payment 1 minus 1 plus R over N to the minus NT. Don't forget that, because if you forget that, this number here is going to be bigger than 1, and your 1 minus that is going to give you a negative number. And we get this formula. Now, this is another one of our main formulas. Now, like all our other main formulas, we can solve for the other guy if we want. And if we solve for the actual payment, we get PV times R over N over 1 minus 1 plus R over N minus NT. And this guy has a name when you write it in that form. Just like how the other guy, we gave it the name the sinking fund formula. This we're going to give it the name the amortization formula. Now, mortality is the root word here, so it actually means death. So it's basically a formula. The language comes from, it's the formula needed to kill a debt. What payments do I have to make to kill a debt? Okay? So, why is it used in that way? Because you can also use this formula to talk about loans. So you can think of a loan as some present value that someone is giving you, and in order for you to make payments back to them. So, in the example that I made before, I wanted to know how much money should I put in now so that I get payments of $1,000 in the future. Turns out when you go and you borrow money from somebody, it's like the role is switched and they're doing that to you. You are their annuity. So they're putting money on you now so that you can give them payments in the future with interest, right? And so if you flip the formula and look at it this way, this is what someone who's giving you a loan is going to use to kind of assess your worthiness as a borrower. That's a part of it anyway. But let's actually go back to the previous example. Let's actually use these formulas to answer the previous example, right? How much do I have to put in now to get payments of $1,000 every month for 5 years? And we're doing 5% APR compounded monthly. So what I can do is, using the first formula, with the payments that I desire is 1,000. So the PMT is going to be 1,000. The R is going to be 0.05. The N is going to be 12. T is going to be 5. So this means the present value, the lump sum in the present that is going to be worth is going to be 1,000. 1 minus 1 plus 0.05 over 12 to the minus 12 times 5 all over 1.05 over 12. So you guys kind of check that out and be aware that in your calculator you have to be careful how you're entering this. I'd probably go from the inside out. If you don't have a calculator that can show everything all at once. So take the 0.05 divided by the 12, get an answer, add that to the 1, get an answer, raise that to a power of minus, you put parentheses around here, 12 times 5, get an answer. Then you can subtract that from 1, then multiply by 1,000, then divide that result by 0.05 divided by 12, and this will also have to be in parentheses. So what's the answer? Anyone has it?
52,990.7. 71.
7-1. Now that's a big chunk of change, to be sure, but let's look at how much did I save? Like how much of this work is the interest going to do for me? Like the total of all payments would be what?
60,000.
60,000. And I put in 52,990.71. So therefore I save it's gonna be 7,000 something. Like $7,010. $7,009 and something. So in the previous example with the one lump sum, we saved like 50 bucks. Now we're starting to save in the thousands. You can see it's starting to add up. But this was a much more ambitious goal. And yes, you still have to deposit a huge amount now, but yeah. You'll gain 7,000. If you're the person lending this money, you would gain $7,000 on your lending investment. Here's another use for this formula. Let me mention the actual, I'll give you two other uses. Here's another use. So I just want you to know what kind of problems you can see and what kind of problems you can use this guy to solve. So in general, any loan problems. So let's say some loaning firm is willing to lend you 100,000 at, let's say, 3.99% APR compounded monthly. So you go try to get a loan, try to get a $100,000 loan. That's how they're charging you. What would your payments be? If you must make fixed monthly payments and the loan term is 5 years. So, if you want to borrow $100,000 now under those conditions, if you have to start paying that money back monthly over a 5-year term, what would the payments actually be? How much is it actually going to cost you on a per month basis to borrow $100,000 under these conditions? It's not completely crazy. This is kind of like a mortgage. Mortgage would be a higher sum. Similar interest rate, they're probably compounded a little bit less though. So basically, you want to find your payments, you're going to use the payment version of the formula that we had. It's going to be the present value times R over N over 1 minus 1 plus R over N to minus NT. So the 100,000 is the present value. They are giving you that money now, and you are going to give them future payments over a 5-year term. So we're going to use this, the amortization formula, with R equals 0.0399, your T equals 5, your N equals 12, and PV is 100. So what payments would it require you to kill this debt? Right? Or you can say amort this debt. That might be a phrase that you will see sometimes. The payments that you will need, it's going to be 100,000. 0.0399 over 12 over 1 minus 1 plus 0.0399 over 12 to the minus, well, it's going to be to the minus 60, but technically it's 12 times. You can type 60 in your calculator, it'll be easier. So, what's it going to cost to borrow 100,000 like that? Yeah?
I got 1,879.54.
That's rent for some, which is
I think it's
kind of like a mortgage.
I think it's 1,841.
That's what I got.
You got 41.
I had 79, 41 might be right, yeah.
I got
41.2.
41.20
Yeah, that's what I got.
Yeah, 41.
Oh, I forgot a 9 in the second.
Oh, like 399.
Yeah, I forgot. I only put 1.
41.
0.2.
Oh, so 20 cents?
Yeah, 20 cents, yeah.
Yeah, so that's what it'll cost to borrow 100,000 here, right? these would be the payments. At the end of 5 years, you would have paid back that loan in full. The debt is paid. It's killed. And it's amorted. Here's another use. Let's say you want to buy a car. Okay, if you're in the market for a new car. After budgeting, you realize you can afford payments of, let's say, $450 a month. Okay? So you looked at all your expenses, how much you spend on rent, food, entertainment, all that good stuff, and you realize, yeah, I can squeeze out $450 in discretionary spending money to kind of spend on a new ride. Okay, so that's the situation. So you know you want a car, you know you can only afford a maximum of $450 a month to pay for this new car. Brand new promotion, okay? All you need is a job and you can get a car with us, right? So you see one of those ads on TV. So car loans for, let's say, 2.99% APR compounded monthly. No credit check, just need a job. Okay. Which is probably why it's the only reason why you probably take a car loan that's compounded monthly. I mean, car loans are usually simple interest. That's the first thing I'd ask, why are you compounding my car loan, dude? Okay, so loan term is 5 years. Let's keep it at the 5-year mark. Now here's the question. What price do you need to negotiate for the car? This is often called the max purchase price. What is the maximum price for a car that you can get under these conditions? Without, of course, putting yourself into debt that you can't manage. You can make $450 a month. Under these conditions, what's the most expensive car you can buy? Right? What's the price where you know I can't go above this price? And I probably need to, yeah, the usual thing, you're making monthly payments, blah, blah, blah. Give you all the information. That's the APR compounded monthly over 5 years. You can afford payments of $450. The question is, how much do you want to borrow? How much? What's the max amount that you should borrow here? called the max purchase price, and you can actually use the amortization formula. So here, you know what the payments should be. 450 is going to be the maximum. R is going to be 0.0299. T is going to be 5, N is going to be 12. And basically what we are looking for would be considered the present value in this case. How much money do I need to borrow now so that I can pay it off using 450 12 times a year? This is going to be the payments formula again. I actually want to solve for the present value. Right? We know what the payments are. I want to know how much can I borrow in the present so that those payments will actually work out in my favor. 1 minus 1 plus R over N minus 1T over R over N. So the maximum price of the car that I can afford would be 450. 1 minus 1 plus 0.0299 over 12 to the minus 5 times 12 all over 0.0299 over 12. So what's the price? Expensive a car can you get for $450 a month in these terms? Yeah?
I got 25,049 and 76 cents.
25,000
49.
and 49
76.
6 cents.
76 cents.
That's that should be the max purchase price. You get anything higher than that, you're going to put yourself into debt you can't manage. Finance, file for bankruptcy, take your death and skip the country. You're going to be put in a tough position if you go higher than that. So of course you're going to go to a dealership and be like, you can only afford 18,000, man. That's when you start. Just kind of make sure to start low so they don't like try to highball you. Yeah.
So that's also the amortization formula.
Yes. You can remember either of them as the amortization form. I'm not going to kill you there. But you should know, like, if you're paying down a debt or paying off a loan, this is going to be the guy you want to use, or you want to actually get payments being made. In fact, that's probably a good thing to do for the last few minutes of class to kind of wrap up and summarize things here. I think that's the last example I want to do. We looked at a bunch of things, and some of them are more straightforward than others. We looked at, in the first two sections of the text, where one-time payments are being made. So we looked at 3 situations with simple interest. This was with your A equals P times 1 plus RT. This means interest is assessed only on the principal over some time period. it grows very slowly compared to the other forms of interest because it grows like a straight line. We also did compounded interest. This one grows a lot faster, especially over time. This is where that's going to be the formula. So here's where you're being charged interest on top of interest, and that's being done n times per year at an annual interest rate of R. We also had continuously compounded interest. And this one was the PER formula. PE to the RT. E is a number in your calculator. Should make sure you know how to find that. And these are the more straightforward ones. Why? Because in any problem where you're going to have to actually use one of these, the problem itself is going to like tell you you have to use one of these. It's going to say, oh, assume simple interest, or oh, assume it's compounded 5 times per year, or blah, 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 or oh, it's continuously compounded, right? They'll say that to you. The question is going to tell you. In the sinking fund, though, and the amortization formula, they might not tell you. The word sinking fund or amortization might not even show up. How do you know which one to use? But we also dealt with multiple payments. So this would be like the main stars of this were like the sinking fund formula. And the amortization. Look at this. So the amortization is the one we just did. So that's when the present value is equal to payments 1 minus 1 plus R over n to the minus nt over R over n. So that gave us basically the present value of annuities. And over here, it's the future value of annuities. And that was FV is equal to payments. This looks like 1 plus R over n, and n minus 1 over R over n. Now these are, there's some room for confusion about when to use which, so I probably actually tell you how you are going to use those. So how do you know when you're going to want to use one formula versus the other formula? The perspective is going to be different for each. For sinking fund, what you want to realize is you're making payments now, or over some term, to receive a lump sum in the future. Right? If that's the goal, however the problem is phrased, if that's the goal, you're supposed to be thinking this formula. This one is saying, well, lump sum now to receive payments in the future. Emphasis on the S, multiple payments. Payments now. Okay, so this one is usually if you're like saving up to a goal. There's a parent who wants to save for a college fund, versus this one, you want to pay down debt, usually. So hey, I'm borrowing money for a car loan or a mortgage or whatever, right? You tend to want to use this formula. And paying down debt just means, or to have multiple payouts to yourself, probably. But the idea is lump sum now to get payments in the future versus payments now to get lump sum in the future. And the situation would call for one versus the other. And it might not actually say certain phrases, you just have to understand the situation by reading the the word problem. And one thing you can notice here is that in general, now I probably won't answer a problem like this, but it'll be useful for your project. We can mix and match here. So you can conceive a situation where one is useful in one part of the journey and another is useful in the other part of the journey. So for example, let's say you are naively planning out your life plan, and I don't recommend this life plan necessarily, it's just an example. Like, so you might say you're 20 now, right? And that represents your working life. You want to retire at 60. So here's where you're 60. Right? Then you want to stop working and just live off the money that you've accumulated over the previous 40 years. And after doing some research on your family tree, you realize that, you know what, none of the men in my family ever lived past 80. So at 80, you expect to be dead at 80. Right, so. Now, if you want to know, okay, I want to be able to retire at 60 and live off $3,000 a month for the next 20 years, what would I have to be doing in my 20s, 30s, and 40s, and 50s in order to be able to do that? So over here, you'd apply sinking funds on this side, right? What do I need to be saving now that I'm working in order to have a lump sum at this point that I can stop income? Hopefully have it growing at some interest rate, and you use amortization over here to finish off the journey. And you can mix and match them into one long-term plan. Probably at any given time, you're going to be using both of these in some way, shape, or fashion in your life story. They're definitely affecting you, and you should know about them. This is kind of how you distinguish. Pretty much exactly the time. So you didn't have time for them. We'll probably talk about that later. Do I see you guys tomorrow? Yes. So, a lot of you guys tomorrow.